One of the challenges in troubleshooting device communication is that you're always at the mercy of the devices themselves, often only seeing how the device interprets the communication issues. ProSoft Technology's advanced diagnostic tool for Modbus serial products, the Data Analyzer, allows the user to take a virtual microscope to the communication port of our ProSoft module or gateway, viewing the exact bytes of data being sent and received before the product performs any interpretation on it. This gives you the clarity necessary to see exactly what's happening on your network. Combined with a basic understanding of Modbus message formatting, the Data Analyzer will allow you to know and thus accurately troubleshoot the communication taking place on your network at a level status displays alone simply can't achieve. In this video, we'll be going over the Data Analyzer mode in ProSoft Configuration Builder software. We'll see how to access the Data Analyzer mode, how to configure it, we'll break down how the Modbus messages are composed, and finally we'll go over how to use the analyzer to capture a communication log. This is intended as a supplement for our lineup of product training videos that walk you through the full configuration process. To begin, I have a project open in ProSoft Configuration Builder with the module that I'll be using for this demonstration, an MVI56E MCM. It's already been configured in RSLogix 5000, I have it running on a network, and I have my PC connected to the module's configuration port. Now, in order to access the Data Analyzer, we'll need to open up the Diagnostics menu. So I'll select my module, then go to Project in the menu bar, and go down to Module and select Diagnostics. Or alternatively, you can just right-click on the module and select Diagnostics. Once the Diagnostics window opens, we see the main menu with the tree view of our module and all the configuration and diagnostic information for the backplane, the database, general info, and the ports. To start the Data Analyzer, you just click on the Data Analyzer button in the menu bar. But before we do that, we'll click the Setup Data Analyzer button. This allows you to select the application port that you want to analyze, as well as set the timing marker frequency. The timing marker is a symbol that the module will output at regular intervals to help you keep track of the timing of events when you look at the data log. For applications where timing isn't an issue, you can just select none. Otherwise, 10 milliseconds is a pretty good value to start with, or 1 millisecond if timing is a critical factor. Once you have things set up, you can close the window and start the Data Analyzer. And this will show us the raw data bytes coming in and going out from the selected application port on the module. You should note that when the analyzer is running, the program execution will slow down slightly. So it's recommended that you only use this tool during troubleshooting sessions. Let's take a look at the data and what the various characters mean. First off, all the data that we see is in hex format. This is the recommended format to view data, including ASCII-based messages, because not all ASCII characters will display in the diagnostics window. The first thing you'll probably notice when you look at the feed from the Data Analyzer is that there are a lot of _TT underscores repeated over and over again. This is the module's timing marker that I mentioned earlier. I selected 10 milliseconds, so the module will print a single _TT tick for every interval of 10 milliseconds with no data on the line. Whatever frequency you select, that is the iteration of time that each marker will represent. Now once you know to filter out all the timing ticks, you'll start to see the actual message data. Hexadecimal numbers enclosed in left and right arrows, and in brackets. The data enclosed in the brackets represents the message that's being received by the module through the port, and the data enclosed in the arrows are messages being transmitted on the port. The R+ with arrows signals that the module has raised the RTS, or request to send, pin to a high state, while R- means the pin has been set to the low state. As you look through the analyzer, you'll notice that whenever you see R+, meaning the line is set to a transmit state, it's followed by data enclosed in arrow brackets. which is the transmit data. And when it gets to the end of the transmission, we get an R- enclosed in arrows that signifies that the module is done transmitting and is now ready to receive data back. And if communication is working properly, then the next message you see will be enclosed in brackets, signifying that it is indeed a received message. So now we'll do a quick overview of the message composition. In the case of a master sending a command out, in between the R+ and R-, we have a series of characters in arrow brackets. This message represents what a typical read command would look like. The first part is the node address on the network, which is 1, then the function code of 3, and the next several characters refer to the data requested or being sent. The starting address, which is 0009, which would translate to Modbus address 40,010, the register count of 1, and finally the checksum. Now in the case of a reply message to this request, we would get the node address and the function code repeated back, then the number of bytes of data to follow, and you can see we have 2 bytes, then the requested data itself, which in this case is 007B, which in regular numeration would be 123, and the checksum. What you'll typically want to do when troubleshooting is to start the analyzer and then capture a few minutes of data going back and forth. Then you would turn off the analyzer and go back through the capture file to determine what the communication problem might be. Before beginning a capture session, you have the option to go up to Log in the menu bar and select Clear Log File. If selected, this will clear your previous log file data whenever you start a new log. If it's not selected, then it will add any data that you log to the existing log file. So then, to save a capture file of your session, we'll go to Log and select Log to File, and this will start logging the diagnostic data that's coming through. After a few minutes, we can go up and select Stop Logging to stop the log, and you can just click the icon again to stop the data analyzer. So now we have a file on our PC that contains a log of all the data transmitted and received by our module during the session. To see the file, go to Log and select View Log File. And this will open up the log file in Notepad. Once it's open, you can select Save As to save the file to a location of your choice. If the ProSoft module is communicating properly with other devices, you should see a steady pattern of commands or requests going out and matching responses coming back. However, if you see commands going out and no replies coming back, then you can assume that the target device is not receiving the command or is unable to respond. If you do see replies, but they have different numbers where the function code should be, that indicates an error with the command, such as the address range is invalid or something along those lines. Or, as you can see here, the command goes out and we get this null character back, followed by a string of unformatted data. This is a good example of an improper response from the slave. This is bad data. And if you see aberrations like this throughout your log, it does suggest that something is amiss on your network. If you find you would like some professional advice with a specific communication issue, you can also email this file to ProSoft Technical Support. Again, just go up to Log and select Email Log to Support. Be sure to include a detailed explanation of your issue or follow up your email with a call to ensure that our support can provide you with the best and quickest answer possible. Well, that does it for this video. We hope that you have found it helpful. If you do have any other questions, you can contact our technical support. Thank you for watching.